guys, today's lesson is on simplifying radical expressions review. The first thing we're going to discuss are perfect squares. Perfect squares are numbers made from multiplying a number times itself. So for example, the first perfect square, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, the next one would be 16, 25, 36, 49, 64, 81, and 100. When we take the square root of a perfect square, we know the answer to them because we know what number times itself equals that value. So from numbers 1 through 6, we're taking the square root of a perfect square, and they're asking you what number times itself is the value inside the radical. For example, number 1, what number times itself would be 25? That would be 5. For number 3, what number times itself would be 9? That would be 3. And for number 5, what number times itself would give us 36? That would be 6. The problems in the section below this, as you can see, are not on our perfect square list. Therefore, we don't know the exact number that could be multiplied by itself to get the number inside the radical. What we're going to do is simplify these radical expressions, meaning making the value inside the radical smaller by using our perfect squares. What we're trying to do is to find the biggest perfect square that goes into the number inside the radical and use it to simplify. For example, problem number 1 in the next section, we want to do the square root of 12, which asks us what number times itself would give us 12. As you can see, 12 isn't in our perfect squares list, so we can't necessarily answer that. If we use a calculator, we'll get a decimal, but for our usage, we want to simplify and keep it in radical form. The biggest perfect square that goes into 12, I'm using the list above, the perfect squares list. The biggest perfect square or number in that list would be 4. So I'm going to break this up into actually a multiplication problem and say that the square root of 4 times the square root of 3 would be the square root of 12. The reason why we're first using a perfect square is because we know the value of it. The square root of 4 we could simplify to 2 times the square root of 3, which we can't simplify any further. Therefore, that would be our simplified expression for the square root of 12. Or someone has a question. Let's take a look at problem number 3. The square root of 200 is asking you what number times itself is 200. If you put this in a calculator, we're going to get a decimal, but again, for our usage, we want to keep it in radical form. We're looking for the biggest perfect square that goes into 200. Now, there are a couple of different perfect squares that go into 200, like 4 and 25, but we want to find the biggest perfect square. That would be 100 times 2. So we're going to represent the square root of 200 as the product of the square root of 100 times the square root of 2. Again, we're using the perfect square first because we know we could simplify that. The square root of 100 is 10, and root 2 we can't simplify any further. Therefore, 10 root 2 would be the simplified radical expression for the square root of 200. Moving forward, we might have a coefficient out front of our radical expression, like problem number 5, that we'd like to simplify. And this is very simply just multiplying. So to rewrite number 5, we could say that this is 3 times the square root of 18. We'll simplify the square root of 18 first, and then multiply our answer times 3. The biggest perfect square that goes into the square root of 18 is 9, 2 times. So I could simplify the square root of 18 to the expression 3 root 2. However, we don't only have the square root of 18, we have 3 times that. On the next page, we're going to look more into multiplying, and specifically the rule is you're only allowed to multiply numbers outside the radicals together and inside the radicals together. In this case, we're only allowed to multiply 3 times 3, which is 9 root 2, which will be our simplified expression for 3 root 18. Similarly, problem number 7, we have a negative out front of our radical expression, saying that we want to multiply -1 times the simplified expression of the square root of 128. Again, since we don't know what number times itself is 128, I'm going to look above at my perfect squares list and choose the biggest perfect square that goes into 128. Make sure you double check these values at least twice to make sure you're picking the largest number. In this case, 16 does go into 128. However, there's a bigger number on the perfect square list that also is divisible by 128, and that would be 64. 64 times 2 is 128, and if I were to simplify, we would get 8 root 2. Like problem number 5, it's not just the square root of 128 that we have -1 times that, so our simplified expression would be -8 root 2. And lastly, problem number 9, we have 2 times the square root of 49. We actually do know what the square root of 49 is, or what number times itself is 49. As you can see, it is in our perfect squares list. I know that the square root of 49 is 7, so that we could actually evaluate this expression, making it 14. 2 times the square root of 49 is 14. What I'm going to ask you to do is pause the video, try all the even problems that I skipped over, play the video to check your answers. Here are your answers to the even problems on our first page, simplifying our radical expressions. In the first section, again, we have perfect squares. The square root of 121, or the number times itself, that gives us 121, is 11. Number 4, the number times itself, that gives us 4, is 2. And number 6, the number times itself to get 81 is 9. The section down below, simplifying, problem number 2, 9 is the biggest perfect square that would go into 90, 10 times. We could simplify the square root of 9 times the square root of 10 as 3 root 10. Problem number 4, the largest perfect square that goes into 108 is 36 times 3. The square root of 36 times the square root of 3 can reduce to 6 root 3, because the square root of 36 is 6. Problem number 6, we have a number times a radical expression. We could split the square root of 50 up into the product of the square root of 25 and the square root of 2, simplifying that to 5 root 2. And when we multiply it by 2, we would get our answer of 10 root 2. And lastly, number 8, we're multiplying negative 5 times root 27. 9 is the biggest perfect square that goes into 27 3 times. So we would be able to reduce that to 3 root 3. And when we multiply the expression by negative 5, we would get our answer of negative 15 root 3. Our second page here, we're going to do 3 operations: multiplying, adding, and subtracting. We did mention multiplying on the first page, being that the rule is that you could only multiply outside numbers together and inside numbers together. For example, when we do the square root of 3 times the square root of 15, we can multiply 3 times 15 together because they are both inside a radical. Since they're both inside a radical, their product will also be inside a radical. Once you multiply, ask yourself if there is a number, a perfect square, that goes into the number inside the radical, so we could simplify it. In this case, the biggest perfect square that goes into 45 is 9, 5 times. And we could reduce our answer to 3 root 5, since the square root of 9 is 3, and we wouldn't be able to reduce the square root of 5 any further. Problem number 3, again, we could only multiply outside numbers and inside numbers together. So we can multiply the coefficients out front of the radicals. 3 times 4 is 12. And then the radicals themselves together. Root 10 times root 10 would be root 100. 10 times 10 is 100, and since both of those numbers are inside the radical, their product will also be inside. Let's go ahead and see if we could simplify our answer. We actually do know what the square root of 100 is. That's asking us what number times itself is 100. That would be 10. So we now have 12 times 10, which we know is 120. Adding and subtracting is just a little bit different. When you add or subtract radical expressions, you're only allowed to add or subtract them when they have the same radical. These are like adding or subtracting like terms. For example, problem number 1, both expressions have root 11 or radical 11 in them. Therefore, we could combine how many root 11s there are. If I add negative 10 plus 12, that would give us 2 root 11s. When you're adding or subtracting radical expressions, you're only combining the coefficients to like radicals. Problem number 3, as you can see, the first expression has radical 6 or root 6, and the second has root 24. We cannot subtract these because they are not like radicals. What we can do, however, is to see if we could simplify one or both of the expressions, and then maybe we will end up with like radicals that we could combine. In order to simplify 2 root 6, we're asking ourselves, what is the biggest perfect square that goes into 6? In this case, there is no perfect square other than 1 that goes into 6, therefore, we can't simplify that any further. How about simplifying the square root of 24? What's the biggest perfect square that goes into 24? That would be 4. 6 times. We can simplify root 24. We're going to end up with 2 times 2 root 6, or 4 root 6. The expression now becomes 2 root 6 that we couldn't simplify any further, minus 4 root 6, which is the simplified expression for 2 root 24. Now that they do have the same radical, we can subtract them. 2 root 6's minus 4 root 6's will give us negative 2 root 6. What I'm going to ask you to do is try the even problems that I skipped over. Pause the video and then play the video to check your answers. Here are your answers to the even problems on the second page. When you multiply for problem number 2, root 2 times root 8, we get the square root of 16, and we could go ahead and simplify that even further since the square root of 16 is 4. Problem number 4, when you multiply 7 root 30 times 2 root 6, we'll get 14 root 180. We could simplify the square root of 80 further since 36 is a perfect square that goes into 180 5 times. And after you multiply the simplified expression by 14, we would get our solution or a simplified answer of 84 root 5. The second section, when we're adding and subtracting, problem number 2, we already have the same roots, so we can subtract these two expressions. Again, it's like combining like terms, in this case by subtraction, so you're only going to combine the coefficients. 10 root 5 minus 15 root 5s would give us negative 5 root 5s. And problem number 4, as you can see, we don't have the same radical. Let's see if we could simplify one or both of them. In this case, we could actually simplify both of them since 4 is a perfect square that goes into 8 2 times. That expression can simplify to 4 root 2. And 9 is a perfect square that goes into 18 2 times. After multiplying by 2, we would get 6 root 2. Combining our two expressions would then give us 10 root 2. Remember, adding and subtracting, you're not going to add the roots, you're just going to add or subtract the coefficients of like roots. Please let me know if you have any questions.